Good everyone, my name is Graphics. Today we want to solve another exercise on frame structure. Right? Now if you look at this frame structure, it has we're using joint analysis to analyze this. But before that, we need to draw our free body diagram. Now drawing the free body diagram, we are going to have something like this. We have successfully drawn the free body diagram FBD, right? And it's a diagram that shows all the external force that acts on the system. Now because this is a hinge support, we're having two reactions. A hinge support at point A having two reactions. That means the reaction at point A along y-axis is this one facing up, while this is the reaction at point A along x-axis. Our load will always act downward. It can never act upward, right? So that's why you see all this point load is a point load facing downward. Now this is a roller support. A roller support only have just one reaction, and that is what? Our arrow dy. So this is F. You see that the reaction, the roller support, just has one reaction, and this is at point A, point B, point C, point D, E, and what? F. So we've done this, we've done the free body diagram, we have exposed all the support, the reaction, the support in the reaction, all the reaction in the support. Now, the next thing we'll do is to calculate for what? For each of the reaction. Each of the reaction, we have three of them in the name of ROAX, ROAY, and RODY. Now, we write calculating for the reaction, calculating for reaction, right? So we'll say that the first one, we use the three conditions for equilibrium, which is the first one of the condition is the summation of all the horizontal components, which we call f of x, is equals to what? 0. Now we are going to consider, the force acting towards the right should be positive, and the force acting towards the left should be negative, right? Now if you look at this diagram here, we only have one horizontal component in the name of what? ROAX. So we say that my ROAX is equals to what? 0. Now this is the first condition for equilibrium. Now the second condition is telling me summation of all the vertical components in the name of f of y is equals to what? 0, right? So we're doing that, is equals to 0. Now we will say that consider any force acting upward should be what? Positive, and any force acting downward is equals to what? Negative. Now we have 4 vertical force, which is 1, 2, 3, 4. But out of those 4, 2 are acting upward in the name of ROAY and what? RODY. So we say that my ROAY is positive plus what? My RODY. Then the 60 and the 80 are acting downward, so it will be minus 60 minus 80 equals to what? 0. Now if I sum these two together, my ROAY plus RODY will be equals to minus 60 plus 80. Minus 60 minus 8 will give you minus 140, right? So we have minus 140 equals to what? 0. Now if I take my negative 40 to the other side of the equal sign, I'll be having RAY plus RDY is equals to what? 140 Newton, because our forces are in Newton in this question here. So that will be my equation 1. Now the third condition for equilibrium is telling us that the summation of moment about a point, now I'm taking point A, equals to what? 0, and I am going to consider my clockwise moment is what? Positive, and my anti-clockwise moment is what? Negative, right? So let's take moment, and taking moments we need to consider each of those distances. We know that from A to B is 10 meter, from B to C is another 10 meter, from C to D is another 10 meter, right? So each of them is 10 meter each. So we'll take moment about A. So in this case here now, this force here will be going towards A. If you want to understand about moment, you watch my videos on moment. You say the force times the perpendicular distance. So it will be 60 times 10. So I'll go here and I'll place my 60 times 10 here. So it's positive. 60 times 10, right? Plus the next one will be 80 going towards this direction, right? 80 times from here to here is 20. So 80 is acting at point C to back to point A. That is what? Distance of 80. So 80 times 20. So we have 80 times 20 plus, then the third one is RDY, and it's going this direction, that is anti-clockwise this way. So we have negative. So we're having minus RDY times distance from point D to point A, which is what? 30. So minus RDY times 30. So we have minus RDY times 30 now equals to what? 0. So if you do this, 60 times 10 will give me 600 plus 80 times 20 will give me 1600 minus 30 RDY equals to what? 0. So 600 plus 1600 will give me 2200. Now we have 2200 minus 30 RDY will give us what? 0. Now if I take this to this side, my 200 is equals to what? That will give me 30 RDY, because when it comes to this side, the negative side will disappear. Now if you divide both sides by 30, we are going to be having RDY equals to what? 200 all over what? 30. Now from here we'll be having, so if I input this in my calculator, I'm going to have the 200 divided by what? 30, and this will give me 73.33. So in doing that, my RDY is equals to 73.33. So RDY is equals to 73.33 Newton. Now similarly, we are going to substitute RDY into equation 1 above. Now this is my equation 1 here. So we're looking, put RDY so you get RAY. So we say that my RAY plus 73.33 is equals to what? 140. So we'll now say that the RAY will now give me 140 minus 73.33, and then you input it in your calculator. We have 140 minus 73.33, that will give us 66.67. So we have RAY to be equals to what? 66.67 Newton. Now we've gotten our RAY, which is this. We've gotten our RDY, which is this, and we've gotten our RAX, which is in this, right? So this will be my RAX. So we've gotten the reaction, but the question tells us that we should calculate the forces associated with what? With each members of the trusses or the frame structure. So that will be our next stage. So we know very well that from here to here is 20 degrees from the question. So if here is 20 degrees, automatically here also is what? 20 degrees. Right? Because, and if here is 20, here also is also what? 20. We call it corresponding angle. Right? So after we've successfully calculated for the reaction, is to get the forces acting on each member, right? Because there's a force associated to member AB is the member AE, member BC, member CD, member DF, and member what? EF. So we want to calculate for all the forces associated to them. Now, there are different ways you can do this. You can use joint analysis, you can use section analysis, and you can use graphical method. But for the sake of this tutorial, I'll be using joint analysis. So you are going to write using joint analysis. Now the question is, there are different joints. Joint is where two or more members meet. So if you look at this joint, I will show you something here. At EF, there's a force acting like this. We'll call it force along member what? EF. And there's another one acting this way. We'll call it force among member FE. Then we have another one here this way also. We have FAE, right? And we also have FEA. So FAE, seen as FEA. Here also we have this and we have this. This will be FD. Here will be FDF. Here also, if I place it here, I have FAB, and here I have FBA. Here I have FBC, and I have FCB. Here I have FCD, and here I have FDC. So here also I have FBE and I have FEB. So these are the forces associated between each member. This is FBF and we have FFB. So here also I have FCF and here I have FFC. So these are all the members that we have in each of those joints, right? So if I consider which joint would I consider first? The joint that has at least two unknown. So I know RAX, I know RAY, but I don't know FAB, and I don't know FAE. I don't know FAB and FAE. So I can consider this. So if I move there, I'll say for joint A, we want joint A, right? So I'm going to draw what I have here. I will draw it out. So if I draw that, I know I have arrow AX. I also have arrow AY. This is arrow AX, arrow AY, and I have this coming this way, FAB, and this coming this way, FAE. So these are, I'm just considering only this joint and draw the members associated to it. So in this case now we're going to still use the condition of equilibrium to analyze them. So the first condition for equilibrium is summation of f of x is equals to what? 0, and we want to consider forces acting towards the right to be positive and the one acting towards the left to be what? Negative. Now if I do that at this point, I'm going to say that arrow AX is acting towards the right, so I write my arrow AX plus FAB, right? But this is inclined, and when it's inclined, don't forget one towards the horizontal and one coming here this way. So when you resolute it, you'll be having FAE sine 20. Don't forget there's 20 degree here, 20 degree there from this point here, this 20. So we're having FAE sine 20, and at this point here also we have FAE cos 20. Now from here, in doing that, my RAS plus FAB, I'll consider this one, then plus what? FAE cos 20 equals to what? 0. I'm only considering horizontal force. Now we know our RAX from our equation. If you check it, RAX is equals to what? 0. So I'm going to write my RAX equals to 0 plus FAB plus FAE cos 20 equals to 0. Now, if you look at this, we'll now have my FAB plus FAE cos 20 is equals to what? 0. I'll call it equation what? Equation 1. Now I go for the next one, saying summation of what? F of y equals to what? 0. And we are going to consider clockwise upward force to be positive and downward force to be what? Negative. So if you look at this now, we only have one force here facing up, and that is what? Arrow AY. And we have this, when we resolute this inclined force facing down, minus FAE sine 20 equals to 0, right? So my arrow AY is given to be, if you look at it, arrow AY here, let's go there and see. Arrow AY is what? 66.67. So I'll come there, I'm going to put 66.67, so 66.67 minus FAE sine 20 equals to 0. So if I take it to this side, 66.67 will now give me FAE sine what? 20. If I divide both sides by sine 20, my FAE will be equals to what? 66.67 divided by what? Divided by sine 20. So if I use my calculator and I press 66.67 divided by sine 20, that will give me 194.93. So my FAE here will be giving us 194.93 Newton. That's my FAE. Now I'm going to substitute FAE in equation 1. So to write substitute FAE into equation 1. Now where's my equation 1? This is what we have here. So equation 1 is telling me FAB plus FAE. So I write my FAE, I will put 194.93, then cos 20, because my FAE is 194.93. So that one I'm placing it there is equals to what? 0. So my FAB plus 193 cos 20, so times cos 20 times, let us put this way, 194.93 cos 20, that will give me 183.174. to have 183.17 equals to what? 0. So we'll now place it this way and say that my FAB is equals to negative 183.17 Newton. So this is what we have here. That's the first one. Now one thing you need to know is there's something we call when a force is in tension, when the force is a tie, and when the force is a strut. Now if you look at this very well, when you have a force, if I have this is where I'm entering, if a force is going inward, as in going into this joint here, are you with me? When it's going inward, you call it what? A strut. But when the force is coming outward of the joint, you call it what? A tie. The tie is from the word tension, right? And the strut from the word compression. So if you look at this now, my FAE is 194.93. So if you look at FAE is positive and it's coming out, so it means that FAE is a tie. So this guy here is a tie. Now if you look at 194 point, if you look at the 194.1, if you look at the 1 minus 183.17, right, that's FAB, is negative. So we'll go to FAB, and if you look at it, it's going outward. So it means that the correct direction is what? It will be going inward because it's negative. So you redraw this diagram again to show that what? FAB is actually going inward, and that is what? That is a strut. So the negative made it change its direction. So this is what? This is a strut, or you call it a comp. Now we've done for that joint. We'll go to the next joint. So how do you know? We move to our next joint here, which is in the name of this. So I've done for this joint A here. I can go to the another easy joint. Either I can come to joint B. Let's see joint B. If joint B were up out. Now if I look at this joint B here, I don't know FBF, I don't know FBC, I don't know FBE. So I cannot use this joint because the unknown is more than 3, right? So if I come to joint C, the same thing. But if I come to joint D is still better because I don't know only FDC and what? FDF. So I'll use joint D. Or if I like also, I can come and use my joint E, because I don't only know these two here. I will together. So I can if I can use my joint E if I want to. So let's proceed. I'll come to joint D. You can start from any joint as long as you have at least 2 unknown, not more than 2. So for joint D, So we are going to joint what? Joint D. So what do I have there? If I should check, let's see. For joint D, I have this, so I'm going to draw it this way. Let's move upward. I'll draw this, and I have a force going upward in the name of my arrow dy, right? Going upward in the name of what? My arrow dy, and a force coming this direction in the name of my FDC. You're wondering where am I getting my parameters from? If you look at this, this is arrow dy going up at joint D. This is my FDC coming this direction, right? FDC, and we have FDF at 20 degree coming like this. So we have 20 degree FDF at 20 degree. So this is what we have here. Now if you compare it, that joint D, this is what we are having there. Just 1, 2, then 3. So we'll start. The first one will look, if you resolve this, to be like this. Watch my video on coplanar force. You get to understand, or resolution of forces. So this will be coming this direction, and that will give me FDC cos 20, and here will give me FDC sine 20. So we'll start. The first one should be summation of what? F of x equals to what? 0. So we'll say consider upward force to be what? Positive, and downward force to be what? Negative, right? So let's see. Horizontal component, not this. So sorry, to be forward force acting towards the right is positive, and force acting towards the left is what? Negative. Now let's see. We have this acting towards the left, so to be minus FDC equals to plus this also acting towards the left. We have minus what? FDC cos 20, right? Then what else again? Equals to 0. Now if I open, we have minus FDC minus, this is FDC, and this is what? FDF, sorry, this is FDF and also FDF. So let's consider. So it will be FDF cos 20. We have minus what? FDF cos 20 equals to what? 0, right? So from here, when we move forward, we call this my equation what? Equation 1. So for equation 2, it says summation of f of y equals to 0. Now we want to consider upward force to be positive and downward force to be what? Negative. Downward force to be negative here, right? So we will now say that if you look at our diagram from here, right? So we'll come again, and this is the upward force minus arrow dy because it's facing upward, and this is one facing down like this. Upward force is positive plus arrow dy, then this one is coming, that will be minus what? FDF sine 20 equals to what? 0. So from here, the arrow dy we calculated was stated to be 73.33. So we have 73.33 minus FDF sine 20 equals to 0. So if I take this side, we have 73.33 is equals to FDF sine 20. So if I divide both sides by sine 20, we say 73.33 all over what? Sine 20. That will give us our FDF. So if I divide 73.33 divided by sine 20, that will be 214.40. So my FDF will give me 214.40 Newton. That's my FDF. So we've gotten the member. Since you've gotten your FDF, so you put it in equation 1 to get your FDC. So I'll just do it by the side here, or better still, I'll do it here. So if I come, I'll say substitute FDF into equation 1 above. So we have for equation 1 above, we have minus FDC minus FDF. So I'll not put FDF, I'll put this. That will give me 214.40 cos 20 equals to 0. So if I press it times cos 20, that will give us 201. So minus FDC minus 201.47 equals to 0. So this come here, my FDC, my minus FDC, or FDC is equals to what? Minus 201.47 Newton. So if you want to see if it's a struct or a tie for this, my FDF is 214 and 214, right? And it's acting going outward. This is going outward, that is a tie, right? Then FDC is 201, right? So since negative 201, so let's see FDC. This is FDC here, it's going back one, it's negative, so it's following, so that is still leaving. That is a tie also, it's outward, that is also a tie. That is for joint D. So you can consider another joint here, and let's see how it goes. So you've done this joint D, you've joined joint C. The thing you need to understand is, if you have, how many joints do you have? You have 6 joints. You are allowed to solve for at least 5 joints. So if I've solved for this or solved for this, I can decide to take this joint here if I want to. So let's see for joint B. So for joint B, or let's see for, yeah, joint B should be okay. The best one we'll do here is joint C, because I know this and I know this first here, but I don't know these two, so we have 2 unknown. So let's do for what? For joint C. For joint C, we have this. I'll draw it out. I have this here. It's coming inward here in the name of 80 Newton, and this going outward here in the name of FCD, and this coming here in the name of FCB, and this coming down here in the name of FCF. If you look at that, I'm talking about this point here, this. So we use our joint analysis. We're saying summation of what? F of x is equal to 0, Now we want to consider forces towards the right to be positive and forces towards the left to be what? Negative, right? So from here we'll move forward. So moving forward, we have this going towards back, that is minus FCB. This is going towards right, plus FCD, equals to what? 0. Now we have not calculated for FCD earlier because FCD is equals to what? FCD is equals to FDC, right? So what we calculated for FDC here, we end up, we had the FDC calculated here, we have negative what? 201 here. Can you see that? 0.47. So I'm going to input it here. Negative 201.47. So we have minus FCB minus that is 201.47 equals to 0. So when it's coming here, my FCB will be equals to what? 201.47 Newton. That is the FCB. Now, similarly, we'll do for summation of what? Summation of f of y equals to what? 0, right? So we say consider upward force to be what? Positive, and downward force to be what? Negative. So if you do that, we have this facing downward minus 80. We have this facing downward minus what? FCF equals to what? 0. So if I do that, my FCF will give me what? Minus what? 80 Newton. Oh, that's like, this is negative here also, and this is negative. So if you look at this, we know it is a stroke or a tie. It's telling me my FCB is what? Negative, and it's correct. So it's going outward. So that is what? A tie. And my FCF is negative, but this is positive. So I will change the direction. In my new diagram, I will redraw this again, but in this time I will allow the arrow going inward, and that will be what? A strut. So your negative sign or positive doesn't show you whether it is a strut or a tie. It depends on the inward and outward nature of the force. So that is for what? Joint C. So look for another joint here and see. We've done for joint A, we've done for D, we've done for C. Now we can do for B also. So we can do for joint B. So let's see for joint B. So calculating for joint B. Now for joint B, we'll look at this shape here. This is our joint B here, and what I can see, we have something like this. We have this, the force coming in, which is 60 Newton, right? That is 60 Newton. Then FBC going towards this point is FBC. Then we have FBA. We have FBA, FBA, and also we have FBE, 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 right? And we have this at an angle of 20 degrees rise, FBF, right? So this one coming here, which is inclined, FBF. That again. So now, after doing this, we are going to see if you resolve this first here, you'll be having something like this. So the horizontal to be the angle between here is 20 degrees as given in the equation. So we'll be having that is 20 degrees here. You can see that. So when you resolve that, here will be FBF cos 20 degree, and here will be FBF sine 20 degree. Now in doing that, first thing is the condition for equilibrium. You see that the summation of f of x equals to what? Equals to 0, where we want to consider upward force, force towards the right to be positive, and force towards the left to be what? Negative. Right? So when you do that, you discover that we'll be having this going backward minus FBA, this going forward plus FBC, and this also coming direction. In result, we have plus FBF cos 20 now equals to what? 0. Now if you put your value, you know that FBA we did earlier is given to be the same thing as saying FAB, right? So we have, so this is what we have here, the FAB. FBA is equal to what? FAB, and this is it here. FAB is minus 183.17. So I'm going to put it, there's already a negative there. I will have minus 183.17, right? Plus FBC. Now the FBC that we have here is given to be, let's look for that. The FBC is so it's given to be FBC, and they are saying FCB, and that is minus what? Minus 201.47. So we have negative 201.17.47, right? Plus FBF cos 20. FBF cos 20 equals to what? 0. Now if you do that, we're going to be having FBC to give me plus 183.17 minus 201.47 plus FBF cos 20 equals to 0. So in that case, I'm going to say that this will give us, subtract these two, we're going to be having 183.17 minus 201.47, that's 201, and that will give us negative 18.3. So I'm going to put my negative 18.3 plus FBF cos 20. Now when it comes here, to give me FBF will now give me 18.3 all over what? Cos 20. So if you divide 18.3 divided by cos 20, we'll be having 19.47. So that will give me 19.47 Newton. My what? FBF, right? Now you do the same thing for summation of what? Fy. So we have similarly the summation of what? Fy will give me 0, where we are we'll consider the upward force to be positive and the downward force to be what? Negative. So if you look at our diagram here, the diagram that we have here, we say that we have 60 kN acting downward, so it will be minus 60. Here we have FBE acting downward, minus FBE. So we have FBA sin 20 acting downward, minus FBF sin what? Sin 20 equals to what? 0. So we know FBF is what? 18.3. So I'll say minus 60 minus FBE minus, so this will give us minus brackets. We have 19.47 cos what? Cos 20, or sin 20, sorry, sin 20. That'll give us what? 0. Now 19.47 times sin 20, that is 19.47 sin 20 will give us 6.659. we have minus 60 minus FBE, so we have minus this, equals to what? 0. So if we do that, minus 60 minus will give us, we have minus 66.66 minus FBE equals to what? 0. So in doing that, we will say that FBE will give us what? 66, negative 66.7, right? Newton. That's FBE. So that is for joint what? Joint B. Now after joint B, we have other joints here. We've done joint B. So the closest one here is now what? Joint E. So we're going to calculate for what? For joint E. Now, if you look at joint E here, there's it. So for joint E, we're having this way, and this way, and this way. What I mean is, look at it. We have this coming here, which is FEF. This is FEF. Then the one going up is what? FEB. We have FEB. The one going to the other side is what? FEA. FEA. Now the angle in between. Now if you look at this very well, I say it is 20. Since here is 20, automatically this will be 20. They call it alternate angle. So the angle at which this is inclined to the horizontal is 20 degrees, right? So if I resolve it, it's going outward, so I'm having this guy this way and this way like this. So at the upper side, we have FEA sine 20, that is FEA sine 20, and here give me FEA cos 20, FEA cos 20, right? So let's move forward and see. Now from here, we'll do the needful. We'll do for summation of what? Summation of horizontal components will give us. So we'll consider the upward force. The force towards the right to be positive, and the force towards the left to be what? Negative. And when we do that, we discover that this is going towards the right, so we have FEF, right? Plus, or inside plus, look at this, it's going towards the left, and that will be minus FEA cos 20 equals to 0. So if I take it to this side, I'll see my FEA will now give me FEF all over what? Cos 20. FEA will give me FEF, or instead of that, what is my FEA? We've already calculated for FS. AE using as what? EA. So from here, we look at it, we have AE, something as saying EA. This is what we have here. So this is AE, something as EA, and that is 194.93. So from here, let me remove this. So we say that my FEA will be FEF minus 194.93 cos 20 equals to what? 0. So from here, 194 cos 20 will be 194.93 cos 20 will be 183.17. So we have my FEF to be equals to 183.17 Newton. That is my FEF. So we have that to be my FEF. So and we already know my FEB. To get my FEB, I'm going to say that we have FEB, such as FBE initially, right? So if we go to joint B, it's where we have FBE, which is minus 66.7, right? So now we'll do for summation of f of y. Let's see. Summation of what? F of y will be equals to what? 0. So we want to consider the upward force to be positive, downward force to be what? Negative. Right? So downward force is negative. And when you input it here, if you look at the diagram now, this is facing up, that is positive. So it's FEB. And this is also facing up, that is also positive. Plus what? FEA sine what? 20 equals to 0. Now what is FEB? FEB is what we calculated here earlier to be what? Minus 66.7. So we have minus 66.7. So plus FEA is 194.3. We send as FAE. Look at it. FAE since I'm saying FEA 194.93. So we have plus 194.93 sine 20 equals to 0. Now if you do that, you have minus 66.7 plus 194.13.93 times 20 will give us 66.67 equals to what? 0. Now if you look at this, they are the same, so 0 is equals to what? 0. So it shows that what we've done so far is very, very correct. Now it shows that the forces are what? Are the same. So it means that I have my, the sum of the two forces is giving me what? 0 here. So we successfully got all this we've done for joint. So what this simply means is that you don't have to calculate for this force here, Fy, because you already know what Feb is and you know what Fea is. So by the time we inputted them, we realize that we have this. So this is how you calculate for forces in a member in a frame structure. Since we have 6 joints, you need to calculate for only 5, the best possible 5, the way I showed you. And when you are done, you need to draw a table to show all the forces and the members. So after that, you calculate for the member. How many members do we have? Let's see. We have member AB, so you just write your AB. We have member AE, write member AE. We have member BE, write it BE. We have member BC, write BC. We have member EA, we already have that. So the next one is for this joint, we have CB and CD. We have CB and CD. So we move forward. CB, same thing as BC, so you don't have to write anymore. Then CD, we have member DF, we have member EF, and that is all the members. That is, we have member BF. We also have member CF, right? We also have what again? Member EF, EF, and so on. So that the members we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So is there anything we're repeating? We have 9. Yes, we have members 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 9 members that we have. That is GF. So we move forward. Now you start inputting all the values you have in those members. So if you do that, we have at member AB, we'll go to our first solution here. We'll just say that our member AB is given as negative 183.17. So you just write 183.17, right? So in front here you just put Newton to show that everything is in Newton. And the type of force which I showed you earlier is a tie, which I explained when you know it's a tie or not. So it's a tie. A is a tie, then AB is minus 183.17. That's AB. Minus 183.17 is a struct, sorry. So you just write a struct there. How good? A struct. Then this one is AE is given us 194.93, 194.93, and is a tie. Then BE, go to BE, go to joint B. We're going to see our BE there for joint B, right? So we did it here. Joint B here is telling us that BE is negative 66.7, so you just put 66.7, So you look if it's a struct or a tie and you input it there, so and so on. So you do that continuously until you fill the table. So is BE a struct? Let's just do that and see. BE is negative here, and BE here is also negative going downward. So it's leaving, there is an outward force, is leaving this point here outward. So that is what? A tie. So BE is what? Is a tie. Right? So BC also, we'll put our BC. So we have BE. So we have the BC, is something as saying CB. So go to join C and C. So you just complete the table, and you see this is how we'll go about it. So if you found the video helpful, don't forget to click on the subscribe button. Thank you.